Okay, now we will consider about Huygens Principles. Okay, Huygens Principles. Huygens Principles deal with the nature of wavefront. It also gives the idea of what are known as secondary wavelets. It also tells us how to construct a wavefront. So we see what are the Huygens Principles. First principle says every point on a given wavefront acts as a source of secondary disturbances. These are also called as wavelets. So secondary disturbances that spread out in all directions with the same speed of the wave. So every point in a given wavefront acts as a source of secondary wavelets. These wavelets travel with the speed of the wave. This is the first principle. Then the other principle, the new wavefront at a later instant. Okay, you have a wavefront now. You want to construct a wavefront a little later or at a later instant. So the new wavefront at a later instant is given by the common tangent plane to all the secondary wavelets at that instant. So two things are given here, they are very important. Now explanation. See, you are given this wavefront now. Okay, this is given. You can call it as t is equal to 0. Then every point in this wavefront, say such as points 1, 2, 3, 4. These 4 points are sample points. Taking these 4 points on the wavefront, current wavefront, as centers, because these are the points which can act as a source of secondary wavelets. So how to draw the secondary wavelet? Taking these points 1, 2, 3, 4, just for sample, 4 points. Taking these points as centers and taking Vt as radius, because we want to find out the wavefront after a time t. So when time t is equal to t or t equal to tau, anything you can use. So after a time t, from the beginning, we want to find the new wavefront. So what you should do, take these 4 points as centers. Why 4? Just for example, 4 points. Taking these points as centers, Vt as radius. What is Vt? What is V? Speed of the wave. What is t? T is the time interval after which you want to find the new wavefront. You will have to construct spheres, but in 2-dimensional plane we will construct circles. So then the common tangent plane, say tangent plane P1, tangent plane P2, and the wave propagates, let's say like this. Okay, the common tangent planes P1 and P2 are supposed to give the wavefront after a time t. There is one point to be discussed, but before that, let's say P1 and P2 you can say as the wavefront after a time t. This is the starting wavefront. Okay, same thing is there for spherical wavefront also. So it may be some O here. The waves propagate this way. This is the given wavefront. Take points, say 1, 2, 3, 4, etc. Few more are there, but let's consider only these 4. These 4 points as centers. Again taking Vt as radius. Draw circles. Then take the common tangent plane. This one and this one. So this is common tangent plane. Common tangent plane. So they are supposed to represent the wavefronts at a later instant. Let's say that this is t is equal to 0, this is t is equal to t. That's why this distance will be v into t. Distance is speed into time, so v into t. This is common tangent. But here the back wave will be absent. The wave is propagating from left to right. So the absence of the back wave is there. For that, the explanation given by Huygens is the amplitude of the wave in the forward direction is maximum. Amplitude maximum for this. For this wave, amplitude is 0, back wave. Here also amplitude maximum for this. A for amplitude. Okay. Here amplitude is minimum. That's why it's shown as hyphenated line. Amplitude 0. Later on it was proved by very rigorous mathematical treatment, but simply Huygens said amplitude for forward wave, forward envelope is maximum, backward envelope 0. That is why back wave is absent. Okay, you see here, the absence of back wave is explained by assuming that the amplitude is maximum in the forward direction and 0 in the backward direction. Huygens was not able to give very convincing explanation for this, Huygens, but later on explanations were given by using very high mathematical concepts. Okay. Now, why this only forward envelope? For that, the contribution of a wavelet in any direction making an angle theta with the wave normal, in any direction making an angle theta with the wave normal proportional to 1 plus cos theta by 2. Proportional to. And this 1 plus cos theta by 2, you know, this is called as obliquity factor. Obliquity factor. For forward direction, theta is 0. So 1 plus 1 by 2. So obliquity factor turns out to be 1. So maximum contribution for forward direction. In the forward direction. Then in the backward direction, we will have to take theta as 180. So this obliquity factor theta 180 is minus 1. So 1 minus 1 by 2. This will be 0. Obliquity factor is 0. That means no contribution. No contribution in the backward direction. That is why there is absence of back wave. Of course, this is given by a very rigorous mathematical treatment, but the final step only is taken here. The full expression is not given here. What is required only is taken here at our level. So the contribution of wavelet in any direction making an angle theta with the wave normal found to be proportional to 1 plus cos theta by 2. Hence, if you put theta 0, you get obliquity factor turning out to be 1, so maximum contribution. If you take theta equal to 180 for backward wave, so obliquity factor turns out to be 0, so no contribution. Hence, there is absence of back wave. Only forward envelope you have to consider and not the backward envelope.